Assalamualaikum and hi. Welcome to another video for chapter 3, 3.3 Curves of Polar Coordinate. Previously we know that the polar coordinate is represented by the representation of r and also theta, where r represents the distance between the point and the origin and the angle associated with the point. Based on this, we can develop a several polar equation which can form several shapes, which include a straight line, a circle, and also a cardioid. It can also form several other shapes of rose and even spiral. So we will cover 1 until 3 for the content for this subject. We start with a straight line. Suppose we are given this polar equation theta equals to pi over 4 without the value of r. In this manner, the value of r is arbitrary. It means that the point can be in any distance from the origin. Let's try to represent this. The point represented by this polar equation will remain at the constant angle of pi over 4. So you imagine there are infinitely many points that remains at the angle of pi over 4 or 45 degrees. So if you connect the dots, the points there, it will form a simple straight line. And this is true for any given angle. How about if we set the value of r but with any angles? For example, like this. R equals to 3, and this time your angle can be in any angles, but logically it will be in the range of 0 up until the maximum one is 2 pi. So let's mark 3 here, 3 at the top. Imagine there is a point that will remain a constant distance of 3 along 0 up until 2 pi. If you connect the dot, it will be a circle that will remain a constant distance with the origin with the distance of 3. What can we see here? If the given polar equation only gives you a constant of r, it will form a circle with the origin as the center. Let's try another one. This time, for example, if we try to represent r equals to 2 sine theta, like the number C there, the item C. Okay, right now try to do the plotting, which consists of the theta, sine theta, and of course the value of r, 2 sine theta. You can try up until the 2 pi, but for this one I want to make the distinct class of a smaller circle which includes a special angle starting with 0, pi over 6, and so on. 5 pi over 6, and I ends with pi, because until pi we can already see the shape. Try to find the value of the respective sine angle, and also you multiply with 2 to get the value of r. You should get this value, and let's try to represent the points. When the degree is 0, the distance between the point is 0. So let's try to mark it here. Okay. So from 0, when during the pi over 6, the distance will be 1 up until the square root of 2. So it will be around here up until the value of square root over 2 here. It increases to square root of 3 until the maximum distance will be 2. 2 is the highest here. Before it gradually reduces during 2 pi over 3 to square root of 3. Square root of 2, 1 until 0 back. And if you connect these dots, it will form a simple circle with a radius of 1, the diameter of 2, with the center of 0, 1. We can get an idea here that if r is alpha sine theta, it will form a circle, but the center is not the origin. Therefore, r can be plus minus alpha plus minus sine theta, or it can be alpha plus minus cos theta. This is the summary of the general form of a circle, such that the center will not be at the origin. Now let's move on to the shape of cardioid or heart shape. Cardioid falls in the family of a limacon. Later I will tell you what is the difference between cardioid and other shapes of limacon. Suppose we start with 2 plus 2 sine theta, and imagine what are the curves, what is the curves that this polar equation can make. And based on this, again, I want to describe this by using plotting. Okay. For this kind of R, we should start from 0 up until 2 pi to get a full shape. So 0 pi over 2, I limit it to pi, 3 pi over 2, and also 2 pi. Try to find the value of sine theta, and of course the value of r, which is you need to do 2 sine theta first, and then you plus with 2. You should be able to get this value, and let's try to represent the points. When the angle is 0, the distance of the first point is 2 here. So let's mark it here. And then the movement from 0 to pi over 2 or 90 degrees is expanding to 4. Let's say here. And then it goes back to 2 and it's approaching 0 distance. You can also know the value here, but you need to dissect the angles to be much smaller. You need to have an angle here from pi until 3 pi over 2. You can try to verify it on your own to find the actual distance there. Moving forward, from 0, it will grow back, expand back up to 2. Then you will have a cardioid or heart-shaped curves in this form. Let's try another one which involves cos. For example, if r equals to 2 plus 2 cos theta, again, let's try plotting some points. Theta, cos theta, and also the r. I will use the same ranges like 2 plus 2 sin theta just now. Try to fill in the table. You should be able to get these values, and let's try to plot the points. This time, when the angle is 0, it starts at 4. Here, and then it reduced to 2. So it means from here to here. Before it goes to 0, this will be 2 here, 2 back to 4. We still get a heart-shaped function, just at a different orientation. Therefore, the shape of cardioid can be represented either as A alpha, I use A back to make it consistent with the slide. It can be either plus or minus B sin theta. It can also be A plus minus B cos theta. Here is the summary of a general form of equation specifically for cardioid. Now let's proceed a little bit with what I mentioned about the limacon. The cardioid, the general equation, is in the form of A plus minus B sin theta. A cardioid is a perfect heart-shaped curves. Okay. To distinguish it with the other limacon is that the ratio between A and B is 1:1. You can also say that A equals to B. If you get that A is not equal to B, then it will be the shape of a limacon, be it whether it will be outer loop limacon or one inner loop of limacon, but it will not be covered in this subject. To recap, We already covered several shapes, starting with line. Then we proceed with a circle, center at origin. If the value is r equals to alpha sine theta, okay, let me put this in this way, theta equals to a. This one r equals to some value a. Circle, a general one without the center is not at origin, it will be r equals to plus minus, I forget a there, a plus minus sine theta, or it can be r equals to a plus minus cos theta. Still a shape of a circle, just not this, the center is not at the origin, and the orientation is different. We also already covered the cadiode, where the value of r, it can be either a plus b sine theta, or r equals to a plus minus b cos theta, but in addition a over b is 1. You have also more, which is the other types of limacon. It can be in the form of a rose or flower shape, and it can also be in the form of a spiral. Okay, this one is covered in this course. For E, F, G, I might write it in a general manner. Limacon is a plus minus b sine theta, b cos theta, but the ratio is not necessarily to be 1. Whereas the rose, you can try it on your own later, is a cos n theta. The n can be any values, I suppose. You will form a flower shape, or a sine n theta. Whereas the spiral is just a simple r equals to theta. The example is also being visualized in the slide. That's all for this video. We will continue with another video of symmetric tests. Thank you.